Hey guys, welcome back. Today I'm going to show you how to use your calculator to find derivatives and also refresh your memory on how to use your calculator to solve problems that aren't factorable, which does happen a lot on the AP exam. On the AP exam, during the calculator section, it is very calculator heavy and you really need to know how to use your calculators well. Now, how well I can teach this when you're not in front of me, I'm not sure. Wish me luck. Okay, before we get started, let's review something I know you know how to do. Hit pause and write the equation of a tangent. Real quick, go. Okay, equation of a tangent, we need point, we need slope. Okay, to get the point, plug into the original function. We would get 9 minus 3 or 6. To get the slope, plug into the derivative, 2x plus 1, plugging in the negative 3. You get negative 6 plus 1 or negative 5. So the equation of the tangent, y minus y1 equals m times x minus x1. Okay, so why did I make you do all that all over again? Well, what part of this problem can your calculator do for you? Your calculator can find the derivative at a point. It can do just this part, finding the negative 5. It's not going to write the equation of the tangent for you, but it will at least do this part. Now, obviously, you wouldn't use it for this problem because it's quicker to do it by hand, but there are a lot of problems that you can't do the derivative by hand, or at least not very easily. So let me show you how to evaluate this using your calculator. So what your calculator can do is evaluate the derivative at a point, okay? Derivative at a point. If you're plugging in a number to the derivative, okay? Now remember, we already got the answer, so we should get, using our calculator, we should get an answer of, what was it, 5, negative 5, can't quite remember, we'll find out in a minute. All right, so to do this in your calculator, you're going to use a function called nderive. It's in your calculator under the math button. The math button, make sure you go get your calculator, hit pause and get your calculator. The math button is what? The third one down on the left. Okay, I'm going to try to switch over to my computer and show you that now. But you got to remember that this is the function we're doing the derivative of. So you might want to write this down because I'm not in front of you. So we're going to be doing the derivative of this, but we're evaluating it at negative 3. Okay, so we need to know the function we're doing the derivative of and what we're evaluating it at. So my calculator emulator won't look exactly like yours, but it'll work the same. So you have to find the math button on your calculator. It should be the third one down on the left, and hit that. Then you want to arrow down all the way to, I think it's number 8, but we're looking for nderive. So arrow down, and it's number 8. And you can either hit 8 and enter, or arrow down till you see it, nderive, hit enter. Now, depending on what format of the calculator you have, if you have the nicer one, it looks like this. If you have the older version, it will look different, and I'll have to show you that. You have to have an 84 plus or above for this one. All right, we want the derivative with respect to x. This is always going to be an x right there. What goes inside here is the function we're doing the derivative of, which was x squared plus x. Okay, so we have x, oops, I have to click it over here, x squared plus x. Okay, that's the function we're doing the derivative of. Now this spot is where I tell it what value I'm plugging into the derivative. Okay, where do I want the derivative evaluated? And we're evaluating it at negative 3. Okay, now remember we got what, 5 or negative 5 when we did it by hand. So what does this tell us? Oh, crud, nothing. Apparently I messed it up. Choose go to whenever that happens. I did something wrong, but I think it's just because I'm working on a computer. Let me hit pause. I'll come back. Okay, I think I fixed it. Because I was typing on the computer, I think I hit a minus instead of a negative because I didn't use the actual calculator keys. All right, so it doesn't look any different to you, but it is a little different. Now, hopefully when I hit enter, it's going to tell me the value of this derivative when you plug in a negative 3 to it. So it's going to do the derivative for me and plug in the negative 3. And there you go, -5. Okay? So n derive is for calculating the derivative at a point. So now try it again doing this problem. I could do this by hand if you remember how to do the derivative of 5 to the x plus 3, which, by the way, it's 5 to the x plus 3 times the natural log of 5. And this is a product rule. This is not the most pleasant thing. But the calculator will do it for me. It's going to give me a decimal and it won't have the natural log in it. But I just want to make sure you know how to use n derive. Okay? So plug the equation in. N derive is math 8. Hit pause, see if you can do it on your own, and then I'll walk you through it. Okay, so I'm going to do n derive, which was math, either arrow down or just type in an 8. It won't matter either way. Math 8, there you go. This bottom box is always an x because it's with respect to x. Inside this, we're doing the derivative of this function, x times 5 raised to the x plus 3. Okay, and this box here, that's where you're evaluating it. We're evaluating it at -2. Make sure you hit the negative, not the minus. That'll mess you up, and you'll get that message that I got a minute ago. Hit enter. What'd you get? -11.094. Now in this class, now that we're doing calculator problems, on the AP exam, you should always, always, always round to the nearest thousandth, 3 digits to the right of the decimal. If you don't round correctly and you get the right answer on a free response question, they won't give you credit. If you round too much so for this answer, my final answer on the paper would be -11.094. You can go further out, but you cannot go less. Always 3 digits to the right of the decimal. Don't forget it. If you do all your math right and you say that the answer is this on the AP exam, they do not give you credit. Okay? Always 3 digits to the right of the decimal. So that's how you use n derive. And again, what is it used for? Evaluating the derivative at a point. Now, the next thing I have to show you is what you need to do if your calculator is a TI-84 or less and it doesn't have those fancy pretty little boxes, okay? So if you have a TI-83, for example. So for everybody, we have a mode button in our calculator, and I'm going to show you what that does. If I hit mode, okay, a lot of this we don't use that often, but in this case, if you have the nicer calculators, if you arrow down, arrow, 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 all the way to the next screen, okay, see where it says math print? Math print is the one that gives me those pretty boxes. It gives me I can type in a fraction and it looks like a fraction. But they didn't used to have that with the earlier calculators. So I'm going to move this to classic. You won't want to do this really, but those of you who don't have an 84 plus, this is what your n derive is going to look like. I have to hit enter. Okay. So I'm going to do the same thing. I'm going to do n derive again, just so you can see how it looks. It's still math 8. But now look, it literally says n derive. Okay, so how do I put this in? How do I evaluate a derivative at a point if I have this type of calculator? If you don't have this type of calculator, you're welcome to just fast forward through this. So I'm going back to the bell work question to evaluate it with this format of a calculator. Okay, so you still do math 8. You plug in the function first. X squared. Oops, let me scooch this over. Okay, x squared plus x. Comma. The comma is above the 7. Okay. X, you're going to put another x, always. And then another comma. Now, the purpose of what we just did right there, the x after the comma, that last x I just did, is saying we're doing the derivative of We're doing the derivative of this function, x squared plus x, with respect to x. And now I don't know if you remember, but we were evaluating it at -3. So now the next thing I need to plug in is at -3. So over here, remember we were plugging in -3 and we're supposed to get -5. Okay, so at -3, parentheses. Okay, so only if when you hit end derive, if you get this, you have put the function in first, a comma, then always an x, and then where you're evaluating it. And we should still get -5. It just doesn't look as pretty. It's a little harder to work with, and you got to remember that. Okay, this is also in your textbook if you need to look it up again. So what does all this stuff mean? It means the same thing as if you had the other type of calculator, but that one makes it look more the way it normally does. The derivative of this x squared plus x, normally we'd say evaluated at x equaled -3. That's how they write it on paper, right? So this is the same in your calculator. It's the derivative with respect to x. Otherwise, it looks pretty much the same. Okay? All right, end derive, evaluating the derivative at a point. Now, the other thing end derive will do for you is graph a derivative. So if you know the original function, end derive will graph its derivative, which that can come in handy too, so I'll just show you how that works. Okay, go to the y equals screen and enter this equation into your y1 like you're going to graph it. So I went to y equals. Now I'm going to type in this equation, x cubed, x math 3 minus 3x squared minus 4x plus 12. Now you can graph that if you want to see what that looks like, but that's a positive cubic. Okay, so you should expect it to go, it should go something like this, positive cubic. Okay, let's look at that graph if you want to. Hit graph, top right corner. And that's the graph of my original function. All right, now I'm going to graph its derivative. Well, if this is an x cubed, the derivative graph should be an x squared equation, but here's how you do it. I'm going to go to y equals. I'm going to ask the calculator now to graph the derivative of that. Okay? So, end derive of this. I think I have to change my format back. I think I still have the old version. Okay, so now we're going to do the derivative of y1. So, end derive, math 8 of the top equation, but there's always an x in this first box. Okay, in here, you're either going to retype all of this stuff, or you retype the whole equation, x cubed minus 3x squared, all of that, or just tell it you want y1 to go there. Well, how do you get to y1? That over here on the right side, okay, again, I can either type in all of this again, or I can tell it to just put y1 there. Well, to do that, you're going to hit the vars button, 3 buttons above the 9, okay, and I'm going to look for y1 right now. Okay, so you hit vars, y vars, so you have to arrow over. Okay, see at the top it says y vars, so arrow over, and then hit enter. And there's y1. Hit enter. Okay, now this is gonna do the derivative of whatever is in y1. Okay, now normally we evaluate it at a point. Well, this time I want to evaluate it for all of the different points on the graph, so I put an x here. This will now graph the derivative of my first graph, okay? But If you want it to graph its derivative but not show the original function, then I can unhighlight the equal sign on the first graph. I'm going to go up to y1, arrow over to the equal sign, click enter, and now it's no longer highlighted like the other one is. So now when I graph this in a minute, the second graph will show because the equal sign is highlighted, but the first graph won't. So it's going to graph the derivative of the cubic, so I expect a parabola. And there it is. Now, you don't know how useful this is yet, but just wanted you to get familiar with it could be done. All right? So some other things you need to do on your calculator now. The next thing I'm going to show you is how to solve equations that aren't factorable using your calculator. But before I move on to that, let's review how to graph again. Okay, you have to put the original function in there, and then to graph its derivative, you either retype in the function here or you put y1 there. I think it's much faster to put y1 there. You just got to get used to it. It's vars, y vars, and enter. That's it. Okay, you just got to get used to it. All right, the last thing is solving equations that aren't factorable. Okay, so the last part of this lesson is actually a complete review from pre-calc and from Algebra 2. Let's say you're doing a problem, you've done the derivative, and now you're looking for when it's a maximum or whatever. You basically get down to the part where you just need to solve this equation, but it's not factorable because of this being an x cubed instead of an x squared. That's messing me up. Well, the AP people, they do expect you to be able to at least guess and check like 1, -1, 2, -2, and 0. We did that on the last test. But if those don't work and the answer is a decimal, how do you find it? Okay, that's what we're going to do right now. And that is something you should already know. The short of it is we're going to graph in our calculators this in y equals, and we're going to look for when it equals 0. In other words, we're going to look for when it has a height of 0. Okay, so we're looking for the x-intercepts. Now this happens in the middle of the problem. You're not doing calculus. You already did all the calculus, and now you're at that last step where you just want the answer. So I need to make sure you know how to use your calculators to do that. And by the way, no matter how funky it is, on the other side of this equation, like on the right side, you could have an e to the x and all kinds of other junk. Whatever, no matter how complicated it is, take everything that's on the right side, move it to the left side, set it equal to 0, graph the left side, and look for a height of 0. But then you have to actually use your calculator, not the tracing button. Use your calculator to make sure you get the answer correct to 3 digits to the right of the decimal. So let me show you how it's done. We're going to plug this into the left side of the equation. It's going to get plugged into our y equals screen. Okay, so x cubed math 3 minus 2x plus 3. Hit the graphing function, top right button. I'm looking for that point where the graph hits the x-axis, so I'm literally looking for this point right here, but that point may not be an exact number. So I have to use my calculator to find it. Now I have a couple of tricks to show you, okay? So first, it looks like that x-intercept that we're looking at, it looks like it might be -2. If you think it's a nice, neat integer number, then you can make your guess and type it in and see what happens. So one thing your calculator does for you is if you hit the trace button, top right corner, okay? So I'm going to hit this button right here, okay? The top right corner, trace. Okay, if you hit the trace button, hold on. Okay, I hit the trace button once. Now I can type in any number I want to. It starts at 0. I can obviously hit the little arrows to see different values, and I can go, oh, maybe that's -2 point, I can't really tell. It makes too big of a jump, okay? So that's fine, but that's not the best thing. Once you've hit that trace button, You can now type in any number you want to guess at all. I can literally just type in -2 if I think it's at -2. So I'm going to, once after I've hit the trace button, I'm now going to just type -2 and enter. That's where -2 is on my graph. So clearly that x-intercept is not -2. But this comes in handy for checking a lot of different values on a graph. Let's say I want to know what's happening when x is 0. I've already hit the trace button. I can just make a bunch of guesses. 0, enter. There it is at 0. I want to know what's happening when x is 1. 1, enter. Okay, so that's one thing. The trace button allows you to basically just type in any number you want. But if what we want, that x coordinate that we're looking for, if it's a decimal, then we have to use the calculator to get it. It's an x-intercept, otherwise known as a 0. So this is the function you will use a lot to solve equations that we're trying to find when they equal 0. Okay, we're going to calculate something on our graph. So it's going to be on the graph button, but we want, here's the graph button right here. That guy. We want what's to the left of that. Oops, sorry. Hold on. Let me erase that. We want second calc. It doesn't look the same on this computer screen. Oh, no, I see it. We want second calc. It's actually above the trace button. That guy up there. Above trace is where the calc is, and that's for calculating stuff on your graph, calculating answers on a graph. So we're going to hit the second and then the calc button. So second calc above trace. And these are all the things that we can calculate on our graph. We can calculate a value, though that does the same thing that trace did. We're looking for the 0 right now. We're going to do option 2. But option 3, it'll also calculate minimums and maximums, points of intersection for 2 graphs. This is the derivative. You can calculate the derivative on the graph. And this next one is what we're doing second semester, the integral. Anyway, we're going to use the 0. We want to find the x-intercept, or 0. When does my equation equal 0? So I hit option 2 and hit enter. Now it's waiting for it to tell, the calculator's waiting for me to tell it where it wants it. So I can either arrow over to the left of the point I'm trying to find. Remember, I'm trying to find that x-intercept. I can either arrow over and then hit enter. Or I can just hit a number that's to the left. So right now I arrowed over and hit enter. But if I had just typed in like -4, enter, it would have gone there quicker. So now I'm going to arrow to the right and hit enter, or hit a number that's to the right, like 3, enter. Okay? Either way, either arrow and hit enter, or choose a number that's to the right and hit enter. Then, now my graph is going to look, my calculator is going to look in between those arrows for that x-intercept. It always says guess, it's useless, just hit enter. That's the actual x-intercept right there. And you want to round it, of course, 3 digits to the right of the decimal. So my final answer would be -1.893. Okay, so let's review those steps again. To find an x-intercept, hold on. Okay, to find the x-intercept, it's going to be second calc, then you choose 0. Then you have to get to the left of the point you want and the right of the point you want and hit enter. Okay? So rewind, listen to that again if you have to. Good luck, guys. It's very hard to teach this calculator stuff. The work, at least not when you're not in front of me. The work you're going to do today is just really applying the calculator. Okay? Good luck with your assignment. Bye.